Hi there everyone, welcome back to another video covering OCR A-Level Further Maths. Today we're going to be looking at question 8, part of OCR 2019 Pure Core 2 paper. So this is made up of two parts, A and B. A is worth 5 marks and B is a bit smaller, as worth 3 marks. So let's get straight into it. It says, by writing sine theta in terms of e to the I theta and e to the minus I theta, show that sine theta to the power of 6 can be written as this. So the first thing we should be thinking about here is that we have sine theta to a power, and we have on the left hand side, and on the right hand side we have multiples of theta in terms of cos. So if you have covered all the content before, which hopefully you have if you're doing past papers, you should immediately be able to identify that this is probably a de Moivre's theorem question. And this is a pretty standard one, but it's always useful to be able to do this really quickly, because if you know the method, you can do this for anything, whether it's cos to the power of 5 or sine to the power of 11. Even though it might take a long time, you should be able to do it really quickly. So the first thing is to look at the top, where it says, by writing sine theta in terms of e to the I theta and e to the minus I theta. So for me, e to the I theta is usually quite a lot to write. So I just write at the top of my page, z is equal to e to the I theta. And that just means that because we're using Euler's form here, z is any complex number and e to the I theta is any complex number. So they're basically equivalent. Now, what we need to do is we need to show that we have sine theta to the power of 6. So first thing we're going to do is write what sine theta is in terms of e to the I theta and e to the minus I theta. And then from that, once we have what sine theta is, we can then find out what sine theta to the power of 6 is, and then rewrite it to put it in terms of multiples of cos. So the first thing to do is write what sine theta is. Now sine theta, this is something you just have to know and memorize. Sine theta is equal to z minus 1 over z all over 2i. Now there's a nicer way to write that, so I'm just going to rub this out and rewrite it, just because it's a bit more easy when you're doing workings. And that is 2i sine theta is equal to z, oh that's a bad z, is equal to z minus 1 over z. Now, from this, basically what we can do is we know what sine theta is, so all we have to do is raise both sides to the power of 6, and then we can kind of rearrange for sine to the 6 theta. So at the top of this page here, I'm just going to write out two formulas that are really important. Sine theta is equal to z minus 1 over z all over 2i, and cos theta equals z plus 1 over z all over 2. And these are just formulas you have to remember. If you've covered hyperbolics, you should kind of see resemblance between the hyperbolic formulae and the representations of sine theta and cos theta. So they're pretty easy to remember, but they are just things you have to remember. So then we're going to go back to over here, and what we're going to do is we're going to raise both sides to the power of 6. So 2 to the power of 6 is 64. So we have 64. I to the power of 6 is just minus 1. You can use a calculator for these, but you can also just use the cyclical structure of powers of I to understand that. And then sine theta to the power of 6 is just sine to the 6 theta. And on the other side, you can just write z minus 1 over z to the power of 6. So we have basically, on this side, we have minus 64 sine 6 theta. So you can already see that we kind of got what we want on the left side. We just have to kind of take over the minus 64. And on the right side, we basically just have a binomial expansion. So we just have to expand this using normal binomial expansion, which is just regular A-level stuff, so it should be pretty easy. So then we have z to the power of 6 plus 6 choose 1, which is 6, z to the power of 5 times by 1 over z. Then we have plus 15, which is 6 choose 2, z to the power of 3 minus 1 over z to the power of 2. Then we have plus 20, z to the 2 minus 1. Oh, I made a mistake here, haven't I? Sorry. This is meant to be 4, and this is meant to be 2, and then this is meant to be 3, and minus 1 over z to the power of 3. Then we have plus 15, z to the power of 2 minus 1 over z to the power of 4 plus 6 z minus 1 over z to the power of 5 plus minus 1 over z to the power of 6. Okay, so this is very long, but it is just basic binomial expansion. So the next thing to do is basically simplify this down to remove the brackets. So I'm just going to write equal. I'm not going to write the left side again. But what we get is we get z to the 6, and then we get plus 6z to the 4 plus 15. Oh, sorry, I'm forgetting the minuses here. This has a minus here, and we get plus 15z to the power of 2 because the minus squareds are cancelled out. And here we have plus 20 z to the 3 times minus 1 over z all to the power of 3, so that the minus stays. We get minus 20 because the z to the power of 3 is cancelled. Then for the next term we have minus 15, sorry, positive 15 z to the 4, 2 even. And for the next one we have minus 6z to the 4. And the last one is minus 1 over z all to the power of 6. Now, what we can do is we can pair some of these up. So the things that have the same power, we pair up. So we get z to the 6 plus 1 over z to the 6 minus 6 z to the 4 plus 1 over z to the 4. Then we have plus 15 z to the 2 plus 1 over z to the 2. And the last term is by itself, and that's just 20. Then what we can do is we can actually use the formula over here, because we know we have to write this in terms of cos, because that was given in the question. So we know we have to use the cos formula, and now it's pretty simple. We know that we have this formula here, which is also something you have to memorize. Cos of n theta is equal to z to the power of n plus 1 over z to the n. Sorry, 2 cos n theta is equal to z to the n plus 1 over z to the n, where n is any integer really. So now, using this formula, we can say that z to the 6 plus 1 over z to the 6 is just, if we replace n with 6, we can say 2 cos 6 theta is equal to z to the 6 plus 1 over z to the 6. So we can just put in here 2 cos 6 theta. Then for the next one, we could put minus 6, 2 cos 4 theta, plus 15, 2 cos 2 theta, and the last one's just minus 20. And this is all equal to minus 64 sine to the 6 theta, as we wrote before. Now we just have to basically divide everything by minus 64, and you get your answer, which is sine to the 6 theta is equal to 1 over 32, and we have to remember the minuses here. So that would give the final answer, which is basically just 10 minus 15 cos 2 theta plus 6 cos 4 theta minus cos 6 theta. And that is the final answer. So this has taken a while just to do this question, but obviously a lot of this kind of binomial expansion you could do a lot quicker. You don't have to write out every step. But the main things you have to remember for this is this formula here, this form, and these two formulae up here, because they're really important when expanding. And that's basically part A done, because we got a final answer. Now we can move on to part B. So for part B, basically what we have to do is, in the previous part we have written sine to the power of 6 theta in terms of cos thetas. Now here we have sine to the pi over 8. So sorry, not sine to the power of 8, sine of pi over 8. So the first thing I'm thinking is that we probably have to make pi equal to pi over 8, in some of these questions, if you're not immediately getting it, it's always good to just try and then see if you do get the correct answer, because you know what the answer is at the end. It's a show that question. So for show that question, it's always just worth making an attempt if you don't know really where to go. And then I can see over here that I have a root to the power of 6. So what I'm guessing that we have to do is we have to do sine 6 of pi over 8, and we have been given that because we found out in the last part, and then just basically take the 6th root of each side, and that should give us a final answer, because we know that theta, what theta is, so we can find basically an exact solution, and that would give us some root 2's, etc, etc. So we'll just kind of go ahead and plug in pi over 8 into the formula. So that basically what we have to do is you have to do sine to the 6th pi over 8 is equal to 1 over 32, 10 minus 15 cos of pi over 4 plus 6 cos pi over 2 minus cos of 3 pi over 4. Okay, so now basically what we know is that we can find the exact solutions of all the exact values of all these causes. So that's what we're going to do first. Sine 6 pi over 8 is equal to 1 over 32, 10 minus. So cos pi over 4 is just 15 over 2 root 2, plus cos pi over 2 is just 0, so this just disappears. And we know that cos 3 pi over 4 is also root 2 over 2, so that will be another root 2 over 2. Now, what we can do here is we can simplify a little bit further. Sorry, this would be minus, so cos 3 pi over 4 is negative root 2 over 2, so this would be double negative, which is a positive. And you might be able to see kind of where we're going with this. So now if we just simplify a bit further, we can see that we have 10 minus 7 root 2, and all we have to do now is basically take the 6th root of each side, so that will give us sine pi over 8 is, that's about 8, sine pi over 8 is equal to the 6th root of 10 minus 7 root 2 all over 32. And if I times both sides by 2 over 2, just like that, just by manipulating algebra a little bit, then what you get is you get 20 minus 14 root 2 all over 64, which is, these are equivalent. And then you can just take the root 64 out, sorry, 6th root, this should be 6th root here, and that just gives you 1 over 2 6th root of 20 minus 14 root 2. And that is your final answer there. So overall what we've done is we've done some standard de Moivre question, and then a little bit at the end what we've done is they're independent questions but they are related. We've applied a specific example of this general formula that we found in the first part. So it can be a very easy question if you know how to do it, but it can be time consuming if you don't really know what approach to take. So it's always good to look over these questions. Thank you guys for watching, and I'll see you in the next video. Bye.